Hello to all engineers. In this lesson, we will discover how to work with LCD display and using I2C bus connection type. So as you can see, it's connected only with 4 pins, ground, power supply, I2C bus and I2C clock bus. So, and we connected it with calls, API internet calls to get the weather. So when I'm pressing the button, okay, let's take a look. It's making an internet request call and output the current weather. So this is our agenda for these lessons. Let's move to coding. Let's take a look for agenda. For today, we are going to discover LCD 1602 display type with I2C interface. So let's look the principles for it. This is the two lines LCD display with I2C controller, so you don't need to plug all pins directly. We have 4 pins: ground, power supply, one I2C line and one I2C clock line. Then let's take a look for the controller, what's using on it. So this controller, it's 8-bit I2C bus line. It's very detailed and not easy datasheet, but you don't need to discover everything on it. I already did it. So all what you need to know, this is 8-bit input-output extender controller chip, and I use this directly model from SunFounder kit for Arduino, and we can see the references. So what we need to generate byte signals for each memory cell to output a specific symbols for it. Pi4J team made a great job. They already created an interface for it, so I grabbed their byte commands for it, but we will create an interface from the beginning using a Kotlin language and make it more compact and flexible. Okay, like by the tradition, we will start from, first of all, to use I2C bus on our Raspberry Pi. We need to add some dependency. Okay, let's copy that and add to our POM file. Where is it? Dependencies, Pi4J, Pi4J core, Pi4J plugins. Yeah, somewhere here. Okay, then synchronize it. Perfect. Then let's add a display to our configuration. So we can delete those files. We don't need to use it, and rename this configuration JSON model to something like lesson 11. i2c display.json. Yes. So we don't need a service, we're deleting it. And we can copy, so we will have another type of display. We had a display with 7 digits and we plugged it directly and you was using a lot of pins. But let's make, not this, just copy only this part. Yes. So we have a new values for it. We have a connection type. Let's add it to our configuration. In our brain package, we have a configuration. Let's look at it. Oh, I forgot one thing. Yeah, let's add the configuration, connection type, hardware version. Let's add the connection type as string, and let's add those pins. Pin SDA, this is I2C connection, bus line, and 4 clock to synchronize all I2C devices. It's working like USB devices. To one physical USB port you can connect a lot of devices through USB concentrator. And to synchronize all those data, we need two pins, address as string. Yeah, always be more detailed with the names or your values and any configurations, any functions. It's helping a lot for other developers if you work with in large team. Yeah, it's an integer. Int. So we need to highlight the configuration of current display. Why? Because these LCD displays could be different model and configuration. Currently this one, it's a 2-string display, 2 lines, but they have 4 lines, so you need to highlight it, and your display interface should to know about that. Also you can tune the ambient light to background light, or on your display you can turn it on or turn it off physically, and also programmably to send a signal to this controller. What we have to know, we need to know the address of I2C device, because we do not use a pins numbers. We have only one, so like a Raspberry Pi. I have a third version, GPIO. Yeah. So let's take a look for it. So this is I2C lines. But the common mistake, I made this mistake as also, this is a pin number, physical pin number 3 and 5 or 8 and 6, but when you activating, so let's take a look to the our pin preferences, Raspberry Pi configuration. First what you have to do is check, is your i2c configuration was activated. i2c, it should be activated, and when you activate it, your i2c pin is first, but on GPIO directly on Raspberry Pi or with extension board, it could be like a pin number 5, 7, or 4 or 3, but always remember, if you're activating and connecting any devices through I2C line, it's a pin number 1. It's a I2C bus number 1. What else? Okay, so we add the configuration, mention it. Then the address. Oh yeah, the address. Okay, I already create a readme instruction for that. So all what we have to do. Okay, so I plugged this display. So first of all, if you didn't install the plugin or tool to ping your I2C devices, launch this command, but after that, like I2C detect, and you can see. So it means the address of connected I2C device, because you will look multiple devices if you connect it to your Raspberry Pi. So the address for our current display is, where is it? 0x27. It's a hex, but in JSON, JSON doesn't have extended types of values, so I suggest to save it as string, then parse it to byte configuration. So okay, we add it, I believe. Then we already have a parts for display, and we need to create, let's parse the next configuration for the display. So we have a configuration for 7 digits display without I2C. So let's just return if yeah. Yeah, I'm copying up because I already created it. So it's just a display config, hardware model, and let's create utils. I believe we have an utils, math utils. Let's create an util to make less of code. So let's create some file like a filter utils. Okay, and we can create an util font string filter hardware model returning the same string, and we can return this filter not. So okay, let's copy this one. Yeah, return this filter not this, yeah, like that, to lowercase. Okay, and manage it. And we can literally do the same with this. Okay, so hardware model. Filter hardware model contains the same, but filter hardware model, and we don't need a lowercase, I believe. Yeah, okay, perfect. So we're using this one to filter first type of our to parse it and create instances of specific implementation of the display, and we're using this one. What's else? Okay, fun. Return if, yes, return if this contains this, and return this, and if hardware model filter it contains this, return this type. Yes, okay. And let's make, we have an implementations and we have shared interfaces. So let's make this package more structured parts and add another package like base components, and move the display here, refactor it, distance sensor the same, and server the same. Okay, perfect. Let's create another interface for I2c device, because okay, I'm explaining, we have an implementation of this type of display and its extended display interface, but also we need an I2c device, so we should to extend two interfaces. The strong part of Kotlin, we can extend multiple interfaces, and in Kotlin we have we have like a specific type of interface when we create a class. I'll show you. I2c device. We can make an abstract class. What means abstract class? This is an interface, but you can add some implementations. So if you extend an abstract class, it's a semi-interface and semi-class. So a half of the logic you can leave in your abstract class, and another half what should be extended from instance of child class, you will implement. It's very like a cool feature of Kotlin. What we need? We need a Pi4J Pi4J for context for our I2C device to connect our code with hardware part, and we need a configuration for I2C device. It should be separated from a display logic, because you can have different types of I2C devices, different sensors, engines, I don't know, controllers, other parts, your custom boards, circuit boards, anything. So let's send this configuration and receive it from this abstract class i2c device configuration. Okay. Let's create this configuration. This will be a simple data class where our local data class is storing this package. Okay, Kotlin data class i2c configuration, and we need everything from here. What's related to I2C device? Where is our configuration? So we need, I believe, this one. Yep. And we need this one. We don't need, but we don't want to send address hex as string. We already have to parse it and convert to byte hex address. So just during parsing our configuration. Okay. So we have an I2C device. Yep. Let's create. So in interface you can't I'll show you like a var as a string, but you can't set it. It's prohibited in interfaces, but in abstract class we can do it. Okay, that's the reason why I want to use abstract class i2c Pi4J library. Has this specific type. We creating an I2C reference to our I2C device, and we will send a specific command. So let's generate a configuration i2c new configuration builder. We're sending a Pi4J, then we adding what we need to add. ID. Okay, i2c. We have all the hardware model, the configuration, then we shoot to hex address. It's calling bus, and i2c configuration address. Yes, perfect. Then name. Oops, sorry. Name. i2c configuration name. Then bus. It's our physical pin, but do not forget, if you activating I2c interface, your SDA pin always will be equal to first, but physical it's a, I don't know, it's a second or third GPIO pin. I2c configuration pin SDA, we don't need to mention to our builder clock bus. I2c address, configuration address, and of course build. Okay, we generated it. Then add an init function, this and create app function for it. And now we can, I'll show you, abstract fun init device, and it's receiving I2c. What I did, so when we built this abstract class, what's an interface, and it works like interface. It's building the reference for I2c connection, and when immediately after that it's calling this function, but this function is abstract and you override it and in implementation of your I2c device. So we generate a reference, but when we initting device we can create different logic for that. Then we need abstract fun like a reset for engine. It will be moved to position, to some position. For the display you can clear the display and erase data from the previous launch. Protected, but this function, if it's protected, you can't override it. So send command and cmd you sending a byte, not a byte. Okay, return I2c write a byte command. Then we need a delay, duration of nanos, of duration Kotlin time of what's happening. Okay, maybe duration shown from Java of, yeah, of Java. Okay, 1 2 3 4 5 1 2 3 4 5, yeah, 100,000 of nanoseconds. What's up? I don't know what's happening. Oh, we didn't create this function. Yeah. Then protected fun red register. Actually, allow me to copy all these functions what I already created, and one more function like this one. So this is a delay because what is to get all this data. I saw somewhere in tutorial, so we use nanoseconds between send 2 bytes codes that display lets you to trigger it. Okay. Then we create what we should to create. An implementation of our display. Here, Kotlin display LCD 1602. Okay, and we should display config. We should to get Pi4J like from what? From i2c device. Yep. And then and then display config like the same from here. Okay, and then we extending as display and extending as i2c device, and here we're sending a Pi4J and our i2c configuration. We can display config, but we need to convert our display configuration to a shared i2c device. So let's create an util for that. Okay, we have utils. We can add Kotlin file as converters. Converters. Yes. Okay. Let's fun configuration display config to i2c device configuration. Okay, what should we should to create a new i2c device configuration, and here name equal as this name, so we convert one type display config to another type. Kotlin allow that. We create hardware model is this hardware model, hardware version equals this hardware version, pin SDA, this pin SDA, but what if we don't have a pin because it's nullable? Well, so let's add a default settings for that, because for i2c device connection you should to set any pin. Let's runtime setup settings. Let's add 3 more settings. So default SDA pin, default clock I2c pin, and default connection type I2c, because we're mentioning that in our display configuration, because same display can be with I2c controller, or it could be plugged directly. That's why I'm describing so detailed. It's so okay. Default SDA pin, import property, okay, then pin SL, this pin SL or default, but let's see. Yep, here is it. And the last address. So we can decode string as hex address. Integer Java has it, this address as hex string. Integer decode. Okay. No, to connection type. Oh yeah, but we don't need a connection type actually. Why we need it? Because it's already I2c. We're generating an information to make a connection directly to with I2c. So yes, that's all. Then we returning display config to I2c device configuration. Okay. We should to implement from 2 interfaces. One of them is an abstract class. We will do it a little bit later. Private wall column display config. We have a resolution columns, or let me copy first of all a companion object with all these instructions. Yeah, I know it looks scary, but relax. So I grab these byte codes from Pi4J LCD library. They implemented. Thank you guys for that. I'm using your Pi4J library so much and so often. So I took this. This is a correct commands to control the LCD display, print out data, and move a cursors, erase data for everything. And I added default device byte address and default columns and default rows. Okay. Or this one. And then we will do the same with rows. resolution rows, default rows. Why rows? We need a columns. Yeah, here we need a columns, rows, and one more to activate and deactivate backlight for display. Backlight false files by default. Okay. Output print. This is our this is our function. Not here. This is our common function to print to display. We can have multiple displays. So this function it's very good because you never know what type of display, what the connection, how it works, the hardware model, the logic model. You're just calling this function, and we making and different implementation. We have a display text. So let me copy everything of it, because believe me, I wrote a lot of code. I don't want you to make inconvenience, and I just copy that code and explain what's happening to make the video a little bit shorter. So when we initting the device, we send some specific commands to move the cursor, initialize display settings. So i2c device, we calling init device. If we using specific controller for engine, like an engine driver, our implementation of init function will be different, like move engine or servo motor to specific angle, set it to 0. But in current case, we set display to default settings, then we clear the previous data, set the backlight for the display. This is function if we want to reset the display. This function if we want to clear the display. This function if we want to move to cursor, turn off the display, center text line. This is a display line of the text. So we have two lines, so you can output the text on the first line or directly on the second line. This is some calculations. Display text. Here you just receiving the string, and if the first string is ended, the second part of the string are moving to another row, and here is the calculation for it. So if like your length of the column is ended, you move the cursor to the next row and output it. If all your rows and columns is ended, you cut the string, write a specific char from ASCII code table, and you can see we like a setting read write bit register, move the register. This is specific commands to send bytecodes to the controller, display controller. Okay, right. Where we are. Yeah, right. Character, display line, clear line, set cursor to position. If you want to use it, create a character. So we can draw some graphics on a display like hearts or something like that. Scroll right, scroll left commands, send LCD to parts commands. This a specific function, you don't need to know what it's doing. It's splitting your like a byte array to bytes and send it to the controller. Write 4 bits. This is for i2c device. And this is all the commands as constants. All what you need to know. Okay. I hope you understood everything. If no, just look my source code on my GitHub repository or set pause on this video and you can repeat this code. Yeah, it would be too long if I'll write it from the beginning, but I already made it and verified. Okay. We need to create an instances of that. So we are going to our circuit board implementation, because types circuit board implementation, and what we have a display position. No, not here. When we init servers displays, yeah, it's here. When display is here, or display play LCD model type, and we should to check, because this type of LCD display can be plugged as I2C device or not, so you should to create different init functions for it. So this is a class of L2C display, but it's extended as I2C device. So I2C connection, we can have the same display but without a I2C controller. Okay, what is it? So if the connection is I2C, if its connection type lowercase equals connection type, I believe we already added, what is it, settings, connection type, yep, okay, connection type I2C, import this file, body, displays, add display L2C and Pi4J, and it's add the configuration. Perfect. I believe that's all. Okay, so let's add the main logic. We don't need a servers. Action high. What are we doing? Action high. We don't need an action high. We don't need model. We calling distance, and then get distance measure state, get this. Yeah, it's okay. So when we're pressing the button, we using the logic from one of the previous lessons, API request to public weather service. So let's exclude it, this function, this value to wow, city. Oh, sorry. Toronto. Okay. Toronto. City. Well, city. Yeah. Okay, it's not using. Yes. No, I don't want to make it constant. Okay, let's print it. i2c display. We print it out. Okay, we have it. Let's print it out. When we're pressing the button, when we init display, we don't need to set it like a string. Press the button to get weather forecast. When we launch our application, and let's copy. We don't need like on this. We just undo that. The temperature in our city temp to string Celsius. Okay, let's launch it. Double check that everything compiled with no errors. Configuration was parsed correctly. Looks like everything works properly. And I'll check how it works. Yes. What we forgot about it. Let's check it. Display. Okay. And let's take a look. We have is it works, println test. Let's take a look how it works. Is this print output function calling from the specific implementation? No, it didn't. So why it didn't calling? Let's take a look. Did we add distance sensors display? We don't need to verify. That's actually, this is a mistake. Okay, I found. We can check it if, because for our I2c connection we do not have this pin, so if hardware model is not known. Okay, now everything should to work properly. Okay, we have an exception. Yes, I2c device. Right. Device on bus 1. Maybe we made some mistake with displays. We don't want to use buttons. Okay, let me just copy the whole configuration. The whole configuration, maybe we changed the pins. No. Interesting. Let's copy that. Okay. I2c device. Println I2c configuration to string. Interesting. Yeah, sometimes it's happening. Shit is happening. Wait. Pin SDA address 39. Hardware model, hardware version, pin SDA, pin LCA. Okay. main. I guess we forgot something in our configuration. Okay, I'll pause the video and I investigated. It's just sometimes i2c bus is stacking, so it's enough to reboot the Raspberry Pi. I didn't change any code. We did everything in right way, just sometimes to reboot your Pi4J and it works. Now I'll show you how it works.